Today we're going to talk about translating English to algebra. I find that many students are very good at solving an algebraic expression once it's in front of them, but if they're given a word problem, they're less successful at translating the word problem into an algebraic expression, which they can then solve. So we're going to talk about that first step. We're going to talk about translating English into algebra so that you have an expression to solve. And we're going to reference two charts. And both of these charts are available for download on the website. Just follow the link in the description. And we're going to be doing some sample questions from the Specifics Prep SAT Study Guide, also available in the link in the description. So let's get started. So let's look at number 9. It says, when twice a certain number is increased by 7, the result is 16. What is the number? Now again, this question is all about your ability to translate an English statement into an algebraic expression. So let's go through this one word at a time. Okay, so obviously there's no algebraic expression for, or equivalent rather, for when. So we have twice a certain number. So let's focus on that. So twice a certain number is going to be 2 times a certain number. Now a certain number is your unknown, right? Because it's asking for what is that number. So twice times x, right? So twice times a certain number is increased by, okay, that's addition, 7. The result is your equal sign, right? So this one's fairly straightforward. So we can just go like that. I'm just going to copy these down here. But we basically have when twice a certain number is increased by 7, the result is 16. Okay, and that's how you translate it. Now, I don't even need to solve this now because, again, most of you don't have trouble solving. It's just setting up the algebraic expression. So I'll solve this one quickly, but again, it's not necessary. We subtract 7 on both sides. We get 2x equals 9, x equals 4.5, or 9 over 2. You can grade in either one when you're doing grading questions. But that's pretty straightforward, right? Again, the hard part for a lot of students is getting that translation. So let's look at one that's very similar. It says 7 more than twice a number is then twice a number is equal to 16. What is 4 times the number? So again, we have 7 more than, so more than twice a number. Okay, so in this case, it probably makes sense to do this first and then add that because it's 7 more than something else, right? So twice a number, 7 more than is equal to 16, which obviously is very similar to the previous one. So you think to yourself, well, what is the difference between this question and that question? Well, this question's not asking for the number, right? It's asking for 4 times the number, which is another reason why it's really important to R, T, F, Q. I hope you can figure out what those letters stand for. Anyway, so we're going to solve for x again, and we get 4.5, right? But again, the question's not asking for x. It's asking for 4 times the number, right? So 4 times 4.5 is 18, right? Okay, so that's our answer. That's what we would grade in. So 18, bubble in our bubbles. I didn't do it on the previous one, so let's do that quickly. You get the idea, right? Okay, cool. So you can see why this one's a number 9, this one's a number 12, because it has this little trick at the end. Okay, so number 17 is a tough question. It's really, really hard. So if you are not a 17 level student just yet, it's okay to fast forward through this one, because this one's going to be tough. But if you are feeling ambitious, let's do it. Okay, so this one says a student spent a total of $9.60 for pens and pencils. Each pen cost 2 times as much as each pencil, and the customer bought 3 times as many pencils as pens. How much in dollars did the student spend on pens, right? So the answer to this question is how much on pens, right? So dollars spent on pens, right? Now, we don't know that, right? But we don't know a lot about this question, right? The only thing we do know is that he spent a total of $9.60 on pens and pencils. So let's focus on that statement first, sort of acknowledging the fact that we don't know how much each pen costs and each pencil costs, and we also don't know how many of each he bought, right? So the first thing we want to do is identify what our unknowns are here, right? So we don't know how many pens were purchased, so we'll make that X is the number of pens, right? Now, it's the number of pens, right? We'll make Y number of pencils. Now, why didn't I use P and something else? Because that would have gotten very confusing quickly. So X is pens and Y is pencils, right? Now, we also don't know how much each pen and pencil costs, right? So we'll call A sort of the dollar amount for 1 pen, right? So for 1 pen, you can see this is getting sort of confusing already. And B is a dollar amount for 1 pencil, right? So 4 unknowns at this point, x, y, a, and b, right? However, we do know that $9.60 is a times x, that is the cost for 1 pen times the number of pens, plus b times y, right? The cost for 1 pencil and the number of pencils. So that is sort of indisputable at this point, and that is an important sort of first equation to get going. So again, it's the cost of one times the quantity plus the cost of the other times that particular quantity as well. All right, so at this point we have an equation. Unfortunately, we have 4 unknowns. So let's see if we can start setting up some relationships, right? Well, it says each pen costs 2 times as much as each pencil, right? So we have a relationship between A and B, right? So again, always ask yourself which one's bigger, right? A or B, and that'll help you figure out where the 2 is supposed to go. Each pen, that is A, is 2 times as much as the pencil, so it's twice the cost of the pencil. And it's really important to remember where to put the 2 here, because A is bigger, right? So you're going to multiply this one to get to the bigger quantity. All right, good. So we have A equals 2B. And we could also rewrite that as B equals 1/2 A. We'll see which one of those is relevant in a second. And we also have this equation. It says or this expression says bought 3 times as many pencils as pens. So again, we have pens and we have pencils. We want to establish the relationship. It says bought 3 times as many pencils as pens. In this case, this is the smaller quantity, right? So we're going to multiply that by 3. We get 3x, we get x3, whatever, it doesn't matter. And again, we could rewrite that as x equals 1/3 y. And see which one's helpful, right? Now, what's the question asking for? It's asking for how much did the student spend on pens? That is, how much, don't worry about pencils, just how much did he spend on pens? So let's look at the equation that we set up and ask ourselves what represents cost of pens. Well, it's cost of 1 pen times the number of pens, so AX is what we're solving for, right? So we want to see if we can get that by itself. That is, we're going to get rid of the BY. And because we have these 2 other expressions now, we can specifically do that, right? We can create an expression that we can sort of solve for AX on one side of the equation, right? So I'm going to rewrite this guy down here just so we have a little more room to work. We have 960 equals AX plus BY, right? Now, again, we want to get rid of the B and the Y. So we want to express B in terms of A if possible, and we want to express Y in terms of X if possible, right? So we know that B is 1/2 A, so we're going to replace the B with 1/2 A, right? And we also know that Y equals 3X, right? So we put that there, right? And we have AX plus that, and it's 9.6, right? Okay, and then we can just sort of get AX by itself. Remember, AX is the quantity we're solving for. So 1/2 times 3 is 1.5, and we can put a 1 in front of here if it makes things easier. So 1 plus 1.5, 1 AX plus 1.5 AX is 2.5 AX equals $9.60, right? And then we solve for AX. We divide both sides by 2.5, divide by 2.5, and we get AX equals, I think it's $3.84, yeah, $3.84. Whew, that was a tough one. Okay, let me grade in 384, and we're done. Okay, so as I warned at the beginning, this one is tough. This is just about the hardest algebra question you're likely to see on the SAT. But again, it's all about being systematic and knowing what variables you're going to plug in for where. And it's also really important not to mess things up when you see pens cost twice as much as a pencil and 3 times as many pencils as pens. You want to make sure you're putting the 2's and the 3's in the right place. And always ask yourself, which one's bigger? And as a result, the other one's going to need to be multiplied by something for the equivalency to make sense. Okay. But this one says if A, B, and C are positive numbers and the sum of A and B is equal to the square of C, which of the following is equivalent to C? All right. So again, this is a straight, sort of pure translating English to algebra type of question. It's a number 14, right? So it's medium difficulty. But it says the sum of A and B, so we know that the sum of A and B is that, right, is equal to the square of C, right? not the square root of c. That's really important to remember. And the question is just asking for what's the following is equivalent to c. So we just solve for c here. So we take the square root of both sides, and the square root of c squared is c, and that equals the square root of a plus b. Now it's not individualized, right? If you take the square root of a sum, you can't take the square root of each of the parts of the sum, right? You have to take the square root of the entire thing. So that's why a is incorrect and b is the correct answer. So I'm going to be careful with that. Okay, so again, straight translation. And lastly, let's look at number 16. If the length of a rectangle is increased by 20% and the width of that same rectangle is decreased by 20%, what is the ratio of the new area to the original area? So if you recognize that you can use this solve this using your own numbers, that's great. Go ahead. I'm just going to do this one algebraically, again, because the point of this chapter is to really focus on translating algebra. So let's draw a picture just to help us help ourselves out. Okay, so we have the width and we have the length of a rectangle, right? Now, obviously, you're comparing the new area to the original area, so we're going to need to sort of establish a relationship between length, width, and area. So rectangle, fortunately, has a very straightforward relationship between length and width. Area is length times width, right? So the original rectangle has an area of A with a length and width, right? Now, how do we express algebraically something being increased by 20%? Well, let's start with the length, right? Because length is increased by 20%. Well, if the original length is L, right, and you're increasing it by 20%, it's 20% of L, right? So it's increased by 20%, 20 over 100, whatever you prefer, of L, right? It's 20% of itself. So it's L, plus 0.2 L, and that's going to equal 1.2 L. And obviously a shortcut here is just to say, well, it's 120% of L, so it's 1.2. 1.2 is the same as 120%. You get the idea. So let's see if we could do the same thing for W, right? So it's W, and it's decreased by 20%, so it's minus 20%, again, of W. And that is 0.8 W. So our new area, right, is going to be, let's do A sub n because it's a new area, is 1.2 L times 0.8 W, right? As we all know, 1.2 times 0.8 is 0.96. That's what I thought. I just want to make sure. So 0.96 LW, right? So that's this new area. So the question is, what is the ratio of the new area to the original area? Well, the original area was LW, the new area is 0.96, right? So it's 0.96 LW over LW, right? The new over original, right? New original. The LW's drop out. Our answer is 0.96.